Excellent, thank you. When it comes to modernizing your security and your overall posture, there are several criteria that we hear over and over from our customers. It comes back to it just needs to work. Because at the end of the day, every organization is doing their part to protect their customers and their brand, whether that be from malware, ransomware, or advanced adversarial threats. We all need it to work. So by deploying multiple different layers of protection, this is key in ensuring that VMware Carbon Black is able to protect your organization and respond quickly in the case of a threat by deploying updated protection with no end user engagement. Now, ransomware and adversarial threats will often follow a multi-staged approach. From the perspective of a cognitive attack loop, we look at it in terms of 3 phases, starting with initial access, or what is called recon and infiltrate. This is where malware, ransomware examples such as TrickBot and Bazaar Loader will leverage a spear phishing campaign as an initial entry point into your network. You will see here that we are protected with Carbon Black in the standard policy. I'm going to go ahead and open up this spear phishing campaign, which has preloaded TrickBot within it. Now notice the full kill chain of events that you would experience if this were to be successfully executed within your organization. So clicking in on this spear phishing link, as an end user would do, you're going to notice directly on the right-hand side that this is instantly blocked by VMware Carbon Black, indicating this particular file as malware or malicious and terminating that execution. Now let's say that access was attained. If access was attained, adversaries will then move into the second phase of the attack loop, which we call maintain and manipulate. Now the maintain and manipulate phase is where they will want to continue improving their position through things like credential scraping and leveraging native binaries. So here we're going to leverage APT29, popularized by MITRE ATT&CK evaluation tests, but this is something that simulates real-world behaviors so we can step through and actually leverage this native binary of PowerShell to attempt to scrape credentials and elevate privileges as an adversary would. So I'm going to go ahead and list out the credential scraping techniques that we're going to leverage here, targeting technique number 2, as it is local and it will use that binary and it will scrape the credentials. So we're going to go ahead and attack this endpoint. You will see that instantly terminates an entire shell session. On the right hand side, we recognize that an application has been restricted, associating that back with PowerShell here in this case. Now finally, the adversary will want to execute and exfiltrate. Ransomware such as Ryuk and Conti will attempt to distribute across the network, encrypt and destroy data for maximum impact. It's been an additional trend where we have seen that ransomware over the years has become increasingly destructive. So this becomes a very important or critical factor in our ability to restrict this threat. You can see that when we embed Ryuk within PowerShell, we're not recognizing this based on signature, rather we're recognizing this based on the malicious intent of this script. Now our prevention is enabled through context and controls to disrupt and defend. It doesn't matter if it's ransomware or a zero-day attack instance. Now let's pivot into the console to take a look at what the administrators would have access to if this was an event occurring within your environment. So logging into the Carbon Black Cloud, I'm going to be instantly brought to my alerts page where I'll be able to assess what we are just running locally on the endpoint through the console here. Digging in right away to be able to view a visual depiction of this attack detail, what we will see is on our Windows 10 demo machine, we have 2 different process tree branches. Now this process tree is intended to bring and deliver us with the actionable information correlated in a way that we don't have to go in and individually navigate each IOC. So we've got Outlook here invoking this TrickBot.m as we knew to be true at the endpoint from the spear phishing campaign, and we see a termination action occur. This is due to a cloud reputation flagging TrickBot as a known virus, as it should in this case. Now, the second step that we went through was leveraging APT29 to go in and scrape credentials on our endpoint, or attempt to. Now, what an administrator would have in a typical case is the ability to see this termination as well as an encoded command line. But the intention for a typical administrator is to decrease time to resolution and understand full intention of the adversary. Rather than having to go out of the console and decrypt or decode this, we do so on the fly through our powerful reveal functionality. So this takes the encoded command line and provides us a completely formatted PowerShell script so that we can pinpoint exactly what the adversary was intending to do. Here we can see that we were leveraging Mimikatz to attempt to dump credentials. Based on that termination action taking place, we were stopping that based on our behavioral prevention components here. Now, the process tree indicates what was attempting to run in this situation. What you don't see here is Ryuk. Now, if you go back into the alerts panel, there is a separate alert actually indicating Ryuk.ps1. This is important because what this is linking to is our AMSI scripting prevention. This is our ability to go in and analyze a script before it's allowed to execute so that we can track and kill this before it actually runs. So this is pulling out the intention of the script, tagging it with the appropriate TID, MITRE TIDs as well as techniques. And you can see, even though it doesn't execute, we have the ability to associate this with suspicious ransomware activity and we terminate that execution. A key advantage of Carbon Black Cloud is that we want to shift as far left as possible and identify risk for our customers. One of the areas where risk typically gets put on the customer when moving into an NGAV solution is with malware. What we want to do is we want to proactively identify any malware pre-existing on the system. We do not have to wait for it to execute. Notice here there are no run indicators. We simply detect a known virus existing locally on the system, and we can categorize it and quarantine it, all before anyone has the ability to double click. The concern is if you don't do that before it executes, you put the risk onto the customer or yourself here in this case. Because if the cloud is inaccessible or it doesn't categorize it appropriately, that malware that was sitting locally for maybe days, weeks at a time, sitting dormant, is now running within your environment. And if we start to look at ransomware and malware trends, they have become increasingly more destructive over the years, and we want to make sure that you are not impacted by those new destructive malware variants. The reason that this piques my interest even further, however, is that this is classified as a known virus, yet is unknown or not listed on VirusTotal. So this means it is an unrecognized signature, which is not revolutionary, right? We all know that signature prevention in itself is ineffective because adversaries can change hash values very simplistically. So machine learning techniques are deployed here to statically analyze the payload to ensure that if this is actually a malicious payload, we terminate that execution, or in this case, quarantine and automatically remove this particular file. Along the same lines of antivirus protection and migrating away from that traditional AV, we still, for whatever reason, had users picking up USB sticks off of, I believe it was parking lots and sidewalks and plugging it into their devices, or getting distributed at conferences even with embedded malware. So in the base level of our product, we enable the ability to block read, write, and execution off of unapproved removable media, ensuring that we are looking at this problem holistically and solving this with you guys overall for ransomware. I do want to pivot back to the main dashboard here to give you guys an overview of what we are looking at in this console. Now, the main dashboard is to provide unified insights across your entire enterprise. That's endpoints, workloads, and even Kubernetes and container applications. Rolling up that insight so that you guys can see and report on what kind of attacks we're seeing, at what frequency, and also associating that with known vulnerabilities. So if there is something that an adversary can exploit, we can actually report this information right through the console to be able to take action on. But what I wanted to point out on this dashboard is the intelligence that we offer by default. With AMSI scripting prevention, we are deploying zero-touch prevention as well as detection rules to our customers, to yourself here. That means no agent upgrade, no machine learning, no cloud update. It simply gets deployed from the cloud to your assets in this distributed remote workforce. This is excellent so that you don't have to manage those components. So that when a new ransomware attack comes out, we have deployed those new detection and prevention mechanisms to protect you to the best of our ability here. But what that doesn't answer is the what. What is going on with that ransomware? And we have plenty of customers that I've worked with that come back and say, hey, my C-level executive is asking about new ransomware variant X. How are we protected? What does this look like? What is the impact? So streamlining this information into your console, you will have access to all of our threat research around malware, ransomware, and advanced threats. Gives you a summary depiction as well as the ability to one-click query on this IOC string. Now with the default data retention of 30 days with variable data retention also available, this is key so that you can query back across your enterprise to look for any historical indicators of compromise. In this case, we are verified that we have not seen this, knowing that AMSI scripting prevention automatically updates so that it can protect against that variant going forward here. Now, what if your organization has begun to mature beyond just blocking known malware and ransomware, understanding that Carbon Black is handling that for you guys out of the box, and you want to start evolving into a more strategic framework like zero trust implementation? The nature of zero trust is to assume that everything is malicious and only trust what you know, right? Assume that compromise, flip the script so that we don't allow things like malicious or ransomware to run in your environment. How Carbon Black enables this here is through our policy creation. As a customer, what you would be able to do is you could specify that I want to start blocking all unknown applications from executing within my environment. That becomes a scary thing, right? Default deny or zero trust is a very big uplift. So what we need to ensure is that if we are providing this functionality, we provide that operational confidence. Right? Implement this rule and understand what your potential impact is going to be. So through our test rule functionality, this will actually query back across 30 days worth of data retention to associate this with any potential impact that may be caused on your environment. So that when implementing these rules, you can introduce it with confidence. Now, as we know with zero trust is that zero trust and default deny here, it's an uplift, it's a work in progress. And so what you need to make sure is that you're looking at what is trusted within your organization. And so to make this transition easier for our customers, what we have is the recommendations page. Recommendations actually analyzes your data, your environment, starts to look at what applications are generating alerts. What do other organizations do with these particular files? Do they trust them? Do they block them? And provide recommendation for you to be able to one-click review. You can also dismiss, but one-click review and add the approval to the list so that you can continue to operate seamlessly going forward. So as a review, what we have discussed today is prevention of ransomware through multiple different layers of protection. There is cloud reputation, that's signature prevention as well as machine learning. There's AMSI scripting prevention to statically analyze payloads. It's also where we apply our zero-touch prevention and detection rules through. Behavioral or policy level prevention, where we can start to implement more strategic implementations of preventative rules. And we also have our ransomware canary files, which protect access to the master boot record, volume shadow copies, and it does deploy decoy or canary files to block encryption or modification of those files. So with that, I'm going to pause and I'm going to wrap up this demonstration today. Thank you all for taking the time to walk through how we can help you modernize your security posture through preventing things like ransomware and going into more advanced implementations if need be.